Test, 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 test. Get there. Okay, hello everyone. Hopefully we're live already. Just gonna check the health of the screen, make sure it's all looking good. Sorry for the delay. Just I'm finally done with my travel, but this morning was like the first day back, and so it just took me a while to kind of get back into the office and get everything set up. Okay, it looks like we're live. Checking the stream health. Things seems to be coming out. Couple of big announcements today, right? I'll change the week. It's now week 8, all right? So that shows up correctly. Okay, let me see. That looks like it's working. Hopefully, with everything going on, we'll be able to catch up this week because we're running a couple units behind. Looks like there's a couple people out there already. Okay, good. Okay, so let me just check this. So let's start over again. So a couple of quick things. So this week we will be doing units. We'll be finishing Unit 5 and starting on Unit 6. Hopefully, even getting most of Unit 6 out of the way. Unit 6 is about analysis of agent-based models. And so this will really get into, we've had a lot of questions in the chat about like, how do you look at the results? How do you do this? Can you do this for anything other than just exploration, things along those lines? And the answer to all that is pretty much yes. And we're going to talk a lot about that in Unit 6, where we start to look at the analysis. We'll get a little bit more into R as well while we're doing that. The other big announcement is that, of course, the feedback forms, the peer review for the feedback is due today. Or sorry, not due today. Due Friday. Don't mean to scare anyone. Due Friday. And so make sure you're working on that stuff and getting that all put together, right? And there's been a couple questions in the forum about, do we need to upload code? Do we need to upload pseudocode? Things like that. No, I'm just looking for textual descriptions, right? And as you know, some people have asked for a rubric, but the rubric is pretty much what the questions say, right? Like there's a statement that says, and the way this will be graded is you get 0, 1, or 2 points for each of the questions. You get 0 points essentially if you didn't answer the question at all. You get 1 point if you at least put down, like, for instance, agent types. If you mention one agent type, you get a point, right? And then you get 2 points if you've mentioned all the agent types that would possibly be involved in the model, right, and describe them to some extent, right? So the reviewers will just be asked to rate each of those 7 or 8 questions on 0, 1, or 2 on those basis, right? So I am not looking for, like, and pseudocode, all that kind of stuff. Part of the goal of this is just to make sure that you've rethought through that model design. We're going to be putting up the actual model assignment itself shortly. And so I want you to start thinking through that aspect of it now that we've gotten through how to build a model completely. But the other part of it is we're also, the peer review, the feedback system is in beta kind of at Complexity Explorer. So we're also testing that. And so I thought this was kind of a quick, easy way to test that out. And so I want to make sure it's up and running correctly when we go to the actual model review itself, okay? So that's basically what we're planning on doing, okay? So just, please put together your model design document, get it in on Friday this week, by Friday this week. You will have 1 week after that to answer everything, right? So you'll have 1 week post that Friday to do the peer reviews of the 3 other design documents that get turned in. There's a couple of quick deadlines coming up now, and then hopefully beginning October, right? I'm planning to have the actual final assignment go up live. It won't be due for a couple of weeks. We're going to add in probably an extra week because of the just some of the delays we've had with getting content up and things like that. So we'll probably plan on wrapping up the course at the end of October. Originally, it was going to be the middle of October. That's the basic idea. So you'll see. So you should start working on your model even as you're working on the design document, right? That should all come together. So that's it for the announcements, basically. Let me know. Hopefully, this it sounds like people are saying that there's no lag on the YouTube stream, which is nice. So it must have just been the bad connection I had in Atlanta while I was there. So from now on, not planning to travel for the rest of this course, so we should be good from here on out. Content should be coming up a little more regularly. I apologize for some of the delays in content getting up there. Okay. Yeah, and the screen health is showing me it's only about 99.9% healthy. That's always nice. It's a good measure. So let's go to some of the questions that we've gotten. So I'm going to look at, go to the forums, go to some of the email, and if anybody has a question who's watching on the live stream, you can use the chat window to kind of type in any questions you have in there, and they should show up pretty easily. I'll check those 3 things out, and of course you can always tweet at Intro to ABM as well, and that's also a way to get your questions in. So by the way, for those of you who don't follow the Twitter stream at all, I just want to make a little plug for it. I use it to kind of, I don't want to be pestering people all the time with just random content on social media that I find out. So I post any of that content directly onto the Twitter stream. So if I see anything that's relevant to agent-based modeling in the social media space, it'll probably go directly on the Twitter stream, and you can find it there. Okay. So let's see. So last week so there was one question that came up last week about posting all the code for the various office hours I've done. I'll do that. I just haven't figured out a good place to place it. I guess I could place it in each of the units on the forum. I also, if I write the code, I have no problem posting it up there, even if it's a response to someone else's question. However, if someone sends me their code and I modify it, I don't want to post it up there without getting their permission explicitly to do that first, right? So I will post that up. Sorry, just running a little bit behind on getting that code up from last week, but it will be up there shortly. So everything should be. So let's see other questions we had come in. So there was a question as well. There's an interesting discussion on the forums about the relationship between NetLogo and Swarm. There's a bunch of different. I tried to make this in obvious at the very beginning, right? Though there's a bunch of different platforms out there that are freely available that do agent-based modeling. We're going to use NetLogo pretty much exclusively throughout this class, just because of the fact that I need to choose one platform to keep everyone together on. But I highly recommend checking out other platforms if you want, if some of them might be useful for you. NetLogo for me, though, I've actually coded in most of these. I've coded in Swarm. I've coded in Repass. I've coded in Mason. just a little bit in Mason, not much in there, but pretty extensively in the other two. And I've actually wrote my own agent-based modeling code in C++ before, and in Java at one point as well. And I use NetLogo almost exclusively for what I do. It's probably the best, and the main argument I would make for it is that it is the shortest. It takes the shortest time to develop a model in NetLogo as compared to any of the other platforms. As a result, because my time is somewhat precious. I won't say expensive, but precious at least. And computer time is not as precious, right? I'd rather have the NetLogo models running longer and having me spend fewer times on there. But NetLogo didn't directly supersede Swarm or anything like that. These are just a bunch of different platforms that have come along over the years. They all have their different aspects. And actually, there are people who are still actively using Swarm. There's actually the Swarm Fest meeting, still goes on quite a regular basis. And I highly recommend checking it out. It's a very casual, very not so intensive meeting compared to some. So it's nice from that perspective, in that it doesn't, as opposed to some academic meetings where you feel like you have to get up and really defend what you're doing and you could be attacked. The Swarm Fest community is very, very supportive, and so it's a very nice meeting to go to from that perspective, especially for someone who's just getting based modeling. Okay. There were a couple questions about whether or not there will be another course offering of this. I don't know. There probably will be, so you can tell your friends. Almost assuredly there will be, but you'd have to. I'll have to work with the Santa Fe Institute and Complexity Explorer a little bit to find out when the next time this will be offered. Okay. There were a couple of some people are having issues with test scores not showing up. There seems to be some website issues there. That should be fixed soon. Have I looked at, Lon Thomas is asking, have I looked at release 6 for NetLogo? I've had conversations with Uri Walensky, who develops it quite a bit. I actually just had one with him at Evanston a couple of weeks ago, and I will be having another one actually immediately after this phone call, this office hours with him. It seems like it adds a bunch of cool new things, some of them very interesting. Unfortunately, because of the nature of this course has pretty much already been developed, all materials have been developed, we won't be able to, we won't switch in the middle of the course from 3.1.5 or whatever to the newest release, right? 5.1.3 to the newest release, but we may, future version, 5.3.1. But future versions of the course may very well use release 6, so that'll be a small update. I know there's some important new features coming along, so I'm happy that I think it's a good thing in general. I would definitely recommend, if you get a chance, take a look at it. But we won't be changing it all in the course. Some people were having problems with getting the network extensions to run. Apparently, this may have been a weird issue with just the way different alphabets have different kinds of letters that don't exactly match up. And apparently, NetLogo doesn't perfectly translate into Turkish, is what it looks like. But they found some workarounds for that. Everyone else, I think, shouldn't be having any problems with that. But let me know if you are. Speaking of Lon, who just asked the question about release 6, there was an interesting comment for those of you who don't know. I added this part about Dr. Strangelove at the end of the interview with Tom Schelling. And some of you may not know what that movie is or even what it's about, but a lot of Professor Schelling's work, the reason why he won the Nobel Prize in many ways was actually because of his work he did on analyzing nuclear arms and the Cold War and armament, right? Very little to do with actual. I mean, the reason why the Nobel Prize was won had very little to do with his work on kind of like the segregation model and things like that, right? Instead, it was some of the previous work he had done on armed conflict, right? And he had written a piece, and this is what was described in the interview, about how a nuclear war could start, right? And so that got picked up by Stanley Kubrick, and who decided he was going to make a movie out of it. And so I highly recommend, if you get a chance, please watch Dr. Strangelove, which is subtitled "How I Learned to Stop Fearing and How I Learned to Stop Fearing and Learn to Love the Bomb." Right, and it's a great movie, very funny, kind of black humorous take on the Cold War and on our nuclear war. Yeah, Tom Schelling was a big part of kind of coming up with that and how it went along. Let's see. Yeah, there was also some questions about. Okay, let me pull this about efficiency of some of the ordering in the Java virtual machine. So it turns out on some versions of NetLogo, when you're running the computational efficiency algorithm, the test kit, it actually runs not that much faster with the very efficient version. On mine, it still runs a lot faster in the more efficient version, but some other people that wasn't the case, right? It turns out there have been some changes made to the Java virtual machine since we wrote this book that mean that some of these efficiency issues aren't as important as they used to be. In other words, it's automatically figuring out, for instance, that it doesn't need to keep recalculating one of the variables, right? And so as a result of that, right, the compiler is now helping you write. How can I put this? The efficiency of the code doesn't depend as much on your compiler, right? Okay, so okay. There is when it comes to the progress reports. When it comes to your progress reports on the website, there's this issue that if you'll see a grade of 0 for the model design review until the peer reviews come back, right? So don't worry about it. Just because you see a 0% for the model design review, even though you submitted it, it doesn't mean you're getting a 0% overall. We have to wait until we get the peer reviews back until that gets modified. If I think that's the best way to handle this, right? But if someone has another way that they think that this should be handled, let me know. Maybe there's something. Maybe we could talk to the web designers about adding like a notification or something like that, right? Because right now your score is going to show up as 0% until after you get the grades back. So yeah. Okay. Let's see. Other questions. Okay, so yeah, we already talked about that. There were a couple more questions about just whether or not you need to send in full code or just the actual answers, but just the answers are fine. Okay, another problem with getting NetLogo extensions, but that was all fixed. Okay, well, here's an interesting one. So this is from Shipra Ghosh, who asks, they're trying to create an ABM project, interpersonal interactions between neighbors. They essentially want to characterize a neighborhood of approximately 200 agents into red and blue teams. These could be, for instance, opposing candidates running for neighborhood elections, for instance, right? they want to determine whether over time the neighborhood turns completely red or blue as mixed. Um, the idea is that initially all other agents except for the red and blue ones will remain beige, depicting neutrality. Then immediate neighbors of red or blue will turn red, blue, or remain beige, depending on whether they have good relations with their neighbors. Um, the problem that they're running into is that each individual's agent's relationship with their neighbor needs to be coded beforehand for the model to run in this way. Is there a way to make the model simpler so that only variables that are more global can dictate the outcome? Do you suggest that I reframe my problem and make it more general, or do you suggest that I encode each individual agent's dynamics with their neighbors? So, Shipper, this is a great question. I think this is a very interesting idea. There have been a bunch of approaches at doing what are called voting models. In fact, I have a paper with one of my students coming up in PhysRev shortly that is essentially in this space, right? In our case, we actually look at, it's an agent-based model, but we look at the role of stubbornness, so it's slightly different than your question, in voting patterns, and we show that when you include stubbornness into some of these simple voting models, you get very realistic patterns of behavior. But let me just show you a simple one that exists in NetLogo that might give you an idea of what's going on. This is actually one of my favorite models. We will talk about it later on. I believe when we get to Unit 7, I have it integrated into the class. But this model is called the voting model in NetLogo. And it's very simple. It's even simpler than the model you described, but you could obviously modify it, right? Let me add in a view of that camera. 1 second here. So, just gotta find the right window. Okay, so now we have the right window. You should be seeing the NetLogo window now. Let me turn off the laptop cam, blow it up a little bit more. Okay. So if you go into the models library, and unfortunately the way the screen share works in this, it's not going to show up very easily. But if you go under sample model, social science, voting, right, you'll get a model that looks like this. Okay. You guys are seeing most of the window right now. Okay, good. Let me try. Okay, there we go. And if you hit setup, what it does is it initially creates a world of blue and green individuals. And what each agent in this model has a very simple rule, which is that if the majority of your neighbors are blue, you become blue. And if the majority of your neighbors are green, you become green. And if they're tied, because each of these individuals will have 8 neighbors, right, then you simply remain whatever color you are, right? And so if you run this model, it quickly stabilizes to a particular pattern, right? Where everyone is kind of blue and green and kind of gets locked into their pattern over time, right? Now you can run it a couple different ways. So what if, rather than if the vote is 4-4 and your neighbors are tied, what if rather than keeping the same vote, you actually change your vote, right? So if your neighbors are tied and you're blue, then you go green, and if they're green, you go blue, right? Well, this gets some interesting patterns of behavior where you get similar to the first one that becomes pretty static, but then at the boundary conditions, you get these people who are sitting in tied neighborhoods and just keep switching back and forth, right? So this actually demonstrates. You can think of the first one as a fixed equilibrium, right, because it ends in a particular context. You can think of the second one, though, of it being kind of a cycle, right, where it's moving through a couple of states, right? So now, what if we have something where, like, we have a sympathetic agent? So if the vote is close, so if it's 5-3, let's say, so you're green and 5 of your neighbors are blue and 3 of them are green, right? You become green, or if you're blue, in that case you would become green, right? So this kind of is what they call a word close calls the loser. So whenever the vote is slightly against the loser, right? Not dramatically. If it's 7-1, you still favor the 7 over the 1. Then you basically switch back, right? And this causes some really interesting patterns of behavior to emerge where you see these kind of lumps of individuals coalesce and they kind of move throughout the space. It almost looks a little bit like the life model, which we didn't talk about, but we'll probably get to at some point, right? It's a very interesting kind of behavior, right? And you can turn on both the change votive tide and a word close calls the loser, and you get what I would consider almost like there's some patterns here, right? You get these straight lines that appear, but the basic pattern seems very random in terms of what happens. Anyway, so just to give you an idea of like a very simple model. Now, in your case, right, you also, Chipper, you also mentioned these beige agents, right, who might be neutral between the blue and the green, right? So we could definitely add those in, right? And then you said you want to have some sort of weighting between the individuals and their neighbors, right? Depending upon whether or not they have close ties with their neighbors. And you make a very valid point. I think the point you're really trying to ask here is how do we control individual level characteristics when we want them to be something that we can manipulate at the aggregate level? And that's a difficult question, right? So there are typically two ways to do this, and we talked a little bit about this in 5.1, but we didn't go into a lot of details, right? Because so one way to think of it, you can set an agent's properties by making it fixed. So it could be fixed for every agent in the system, right? In which case, every agent has the same relationships to their neighbors as every other agent, right? It could be drawn from a distribution, right? So this is one way you could solve your problem, Shipra. You could have, say, a mean and a variance of the strength of tie between any individual and their neighbors, right? And have each of the agents individually draw from that distribution, right? And so then your global parameters, you're just defining that mean and that variance, right? Or you could have it spelled out for every single neighbor, right? So you can imagine that you take in some data of some sort from a real world. Let's say you go out and do a survey, and you survey 100 people, and you ask each of them who they talk to and how often they talk to them, right? You could then build a social network up on that basis and then read that data in as the basis of your model, right? So, let me just quickly show you the example. So the last one is a little bit difficult to do, though we'll talk about that later in the course. And the first one should be pretty obvious. That's the one where, essentially that's the one I'm showing you right here, where each agent exactly has an equal weighting with every other agent in there, right? But what about one where they have a variable distribution? So the easiest way to do this would be to do it on a network, right? So let me create a new model real quick. See how quickly I can do this. So let's blow that up a little bit so you can see it better. Okay, everyone. Okay, so you should be seeing, okay, now the model. So what I want to do is I'm just going to create a quick model where I have some agents connected in a random network, much like we did for the diffusion model, right? So I'll create 100 agents. I'll have them, actually I won't have them do much of anything in the create loop because I'm going to create a network around them, right? Okay, so create 100 agents. I'm going to ask the turtles to create a link with, create links with, n of 2 other turtles, all right? So let's just check that real quick. Add my setup and go buttons, setup, go. And of course, we probably want to do a spring layout. I can never get the this right. Layout spring, right? Layout spring. Turtles, links, and I can never remember all the other code. Hold on one second. So the sample code is layout spring, turtles, links, 0.251, which is the spring constant, the spring length, and the repulsion constant. Right? Okay. So I always do a repeat 5 on that just to kind of get it nice and settled out a little bit. That's still not great. Let's do like repeat 50. Get it settled out even more. Right? Okay. So, maybe one thing we do want to do in the create 100 is we want to set their shape to circle, or set the shape to person. How about that? Just since we are building a social model. And let's set their color to one of red, blue. There's no beige in NetLogo, so we'll say green. And green will be the neutral color, right? Or what's a better neutral color? White, maybe white is a better neutral color in this context, right? So we can do setup, and now we have our nice US colored individuals, right? Okay. Anyway, so now we want to have the weights. We want to have the edges have weights, right? That was the big thing we want to add, right? But let's get the voting mechanism down first, real quick. So what we want is we want people that if they have more red neighbors than blue neighbors, they become red. If they have more blue neighbors than red neighbors, they become blue, right? And so what we can do is we can say let red count be count. Ash turtles first. Let red count be count turtles with color equals red. Let blue count. Oh, not count turtles. Count link neighbors. Color equals red. Let blue count be count link neighbors with color equals blue, right? And then just if red count is greater than blue count, set color red. And then if blue count is greater than red count, set color blue, right? Okay. Now in this particular case, right, we're going to assume that if they're equal, you're going to stay whatever color you are. And we're also not allowing people to become white. They either, they start out neutral and then they change, but they don't go back to being neutral, right? So we can set up and go, right? And we get everyone changing except for these 3 white individuals who have exactly tied neighbors, right? But that's assuming, this currently assumes everyone has a uniform distribution of friendship, right? So the big question Shipper was asking was, what if people have different distributions over friendship, right? So what we can do is we can add a slider, call it friendship mean, 0.05 to 1.0, right? Put it 0.5. And we will do also friendship standard deviation, SD, 0.05, 1.0, 0.5. That's a pretty large one, but still, okay. So we'll assume that, that these are the mean and the standard deviation variables. And then what we can do is we can tell NetLogo, so we've talked about how turtles have properties, we've talked about how patches have properties. What we haven't done yet, actually, is show that links have properties. So we can say links own friendship, right? So now we can actually go into the setup and we can ask the links, set friendship, random, normal, friendship, mean, friendship, SD, right? So we can actually ask the links to do something independently of what the turtles are doing. And we'll get into much more of this in chapters 6 and 7, I believe, unit 6 and 7. So now each of the links actually has a weight associated with it, right? And so now we can take this into account. Now let's double check that we make sure we put that up right? So if we go and we just go to one of these and we inspect a link, right? There's now this, well, you're not seeing it very well because of the fact that it won't switch over. Let me just put it this way. Let me do it down here in the command center. So then you should see it, okay? Oh, if I make this a little smaller. Nope, not that. I want to move that. I want to move this window. Can I not do that? There we go. Okay, good. Okay. So now you should be able to see the bottom of the command center, basically, right, where I'm doing this. So I can say, print friendship of one of links, right? So you can get a value. In this case, it's actually a negative value. So I don't know if that means that we could interpret that. We could set it so it can't go negative, right? And I can pull up another value and it's very positive, right? But maybe negative means that the person actually doesn't like that person, doesn't trust their opinions, right? So anyway, so then we can go over to our voting mechanism, and now what we can do is we can say, what we want to do is we want to multiply the weight times the count, right? So we don't want to sum. We don't want to sum up the number of neighbors. We want to sum up the weights of the neighbors with color equals red. So here I'm going to use a cool little thing. So there is actually, if you look at an individual's links in NetLogo, there is two things define a link, right? Which is end1 and end2. So for instance, if I do print links of one of turtles, right? Ah, that's interesting. I would have expected to actually print the links. Hold on. Let me see what it is. Maybe links. Huh. Yeah, it's going to cause a problem because that is actually a turtle. So inspect one of links real quickly. So gotta look at that. I gotta find the command. What I want to find is I want to find the command that gives me all the links attached to a turtle, right? And if I remember correctly, I thought it was just links, but it might be my links because of the fact that links is overloaded. Let's see. Yeah, it looks like it's my links. Okay. Because the reason why it can't be links is because links is the name of is the default breed of links, right? Okay, there we go. So now we have 8 links, right? So if we want to look at one of those, right, it's link 4561. So it's defined by the fact that by the 2 turtles at either end, right? That's what defines the name of a link, right? And so it turns out, right, that there is 2 reporters, N1 and N2, of a link, right? And one. So let's get one particular turtle. So turtle 15, right? So N1, it defines one end of the link, and N2 defines the other end of the link, right? And so what we can do is just simply check to see the color of the other end of the link and check to see what the weight of that link is, right? So the best way to do this, right, because you want to get the end that's not myself and find out the color of that, right? So we want, well, let's first just get all the links that have a red neighbor at the other end, right? So let red links be links, my links, with, so the problem is we got to make sure that we're checking the one that's at the other end. So of all links regardless of this, right? My links, my outlets. Oh, here's what we can do. We can say let red neighbors, as we forward do, be linked neighbors with color equal to red, right? And we'll let red links be my links with either end one, where either end one is a member of red neighbors, or end two is a member of red neighbors. Okay, so this should work. So what this is going to do is, so member takes an agent and determines if it's a member of an agent set, right? And since we don't know if end one or end two for this particular link is the neighbor, right, we're just checking to see if either one of them is a member. And so one of them is going to be me, and one of them is going to be the other end of the link, right? In this case, we're only saying if it's one of the red neighbors. So then now we have all the red links. We can, if you want to check that real quick, right, we can, well, let's do the same for the blue neighbors first. Let blue neighbors be linked neighbors with color equals blue. Blue neighbors. Right, okay. So now let's just put a stop command in here, right? So this will just let it go through the one turtle and stop. It's a little way to do, should, oh, it just stops this task because we're going to go forever. We'll just do setup and go here. Okay, so we just went once, right? Oh, we didn't store that anymore, so that's not going to work. Okay, so what we can do is we can do print red neighbors, print red links, print blue links, print self, stop. Okay, so what this is going to do is going to run the code for one individual. It's going to stop the rest of the routine from happening. Anyways, we'll take out the stop. It's not important. And here we're actually getting agent set 2 links and 3 links, but we're now seeing one of them. So what we can do is we can find agent turtle 61. So find turtle 61. So follow turtle 61. Right. So this is turtle 61 right here in the middle, and we can see, hopefully from inspection, it looks like they have 2 red neighbors and 2 blue neighbors, right? And you can see from here that, one of them is link 761. So 7, 15, 17, and 54 are the 2 that it's linked to, right? So what we can do is we can just simply say report the color. What were those? They were 7 and 15, for instance. Oh, so color is going to show up. So red, I believe, is 15, and blue is 105, right? It's not going to show up as the names. And then 54 and 17. Okay. Oh, maybe there's an extra one there. So we got 2 blue ones. I must have missed one too. 7, 15, 17. Ah, yes, I did. And 64. Right, okay. So I quickly verified that the code seems to be working, and I did it in the following way, right? What I did was I highlighted one particular turtle. I then looked at all of their links, right? And I noticed that it said that there were 2 blue links and 2 red links from looking at the code here, right? I then counted the colors of each of those, right? And 15, which I believe is red, shows up twice, and 105, which is blue, shows up twice. And then there's one other turtle that they're linked to, which is a beige turtle, right? Or sorry, a white turtle in this particular case, right? So this gives me some evidence that the model is running correctly before I go to the next level, right? And I would do this in more detail if I was actually building up the model, but we're running a little short on time as is. So now that I know that I seem to be getting the right count of red links and blue links correctly, I can simply sum the red count as being the sum of the friendships of the red links, right? And I can sum it's friendship, I need to correct that, friendship of blue links, right? Okay. So now it's actually taking into account the weights of the links when making a voting decision, right? And let's just check that real quick. We can, I just like to print stuff out every now and then just to see that it seems to be happening. And so when I hit setup, I hit go just once, you can get a lot of different values. And now the reason why I'm having it print out the values, even though those don't matter too much, the exact values, is because of the fact that I can see that they're kind of all over the place, right? And this gives me some evidence that the model is not just counting the number of turtles now, but is actually taking the friendship into account when looking at it, right? Of course, in order to inspect it even more, I'd probably need to look at one particular turtle, make sure it's getting the sums right, and so forth, right? But anyways, to get back to Shipra's original question, right? This is one way in which I can have every turtle in the network have a slightly different value, right, for their friendships with their neighbors, right, but control it globally because I'm just controlling the overall mean and standard deviation. Now here I'm doing it from a normal distribution. If you want a skewed distribution, you could do that too, right? You could do an exponential distribution or something else, right? But this is, as we talk about in Unit 5.1, there are a number of different ways you can set the variables for any particular agent, right? You could set it equal to a particular value, fixed, right? You could set it equal to a draw from a distribution, or you could set it equal to a particular value but having drawn from like an external data source, right? And then of course you could also have that value somehow update over time, right? So the one thing we didn't talk about here is this friendship value between two neighbors could change up and down over a time, maybe based upon whether or not they vote the same way, for instance, right? And if they vote the same way in one election, then the future elections, maybe they're more likely to be similar in previous next elections than not, right? Also, in this particular case, we're assuming undirected links, right? And so since we're assuming undirected links, it means that each neighbor feels the same about the other neighbor. We could change this whole model to do directed links, in which case you would not have that happening. You could have one neighbor dislike another neighbor more. Right? Okay, well that's the big model I'm going to have time for today. Let's see if there's any other questions that come in. People asked about line numbers. Edward Krug asked about line numbers, but that is actually in Release 6. It's one of the things that got added, right? There's also some questions about the simple economy model, right? And Edward, again, is asking about that. Are there any surveys of all the places the simple economy model has shown up? Not to my knowledge, but yeah, if you find one, let me know, and we'll definitely add it in, okay? Other than that, I think we're done for the day. I just want to recap a little bit about what we talked about at the very beginning. That essentially, um, this week we are covering units 5 and 6, wrapping up 5 and probably the 6. That the design document review is due at the end of this week, and then you'll be getting 3 other design documents that you need to review, right, in the next week after that. And just to tell everyone, this is now permanently where office hours will be. So this URL will not change. It's like YouTube Live, Bill Rand, something like that, right? YouTube.com/C/Bill Rand/live. So every Tuesday at 11, you'll now see us here at this particular location. Yeah, and that's about it for now. If anyone has any more questions for next week, please send them in. Otherwise, I look forward to talking to you in 1 week. Take care. Bye.